bag, is it?
Somewhere here.
So, Michelle, what happened to everybody else, do you know?
I don't know.
I'm sorry, I'm very unorganized.
That's okay.
I tried to wait, but I'm not feeling that too well with flu.
You're sick?
Yeah.
Yeah. Most people are. Most people are. Gina Hand, you could throw everything out of the bag and we could all look together.
No, that's fine. I think it's already out somewhere.
Maybe it's in one of your books.
Yeah, probably.
Is this it? No, that's a worksheet.
That's the worksheet you gave us today.
In here?
Might be. Sorry. Yep. Yeah.
Wonderful, wonderful. Now, where's the oh, these are, oh, do you have the questions?
Oh.
I don't think I could work out the questions from the answers. You don't have the question sheet.
I don't think she gave us the question sheets.
Well, you have to have the questions to try these.
No, I mean, I don't think she gave us back.
I see. Oh, she gave me this back. I understand. Okay, that's okay. So what will we have a look at then? Michelle, what topic has been causing, or you, Ray, what topic has been causing difficulty lately?
We just took the most recent class. I really didn't understand anything.
What was that?
It's in the worksheet that I just showed you.
Oh, the practice,
Yeah.
the revision questions.
Mm-hmm.
Is it practical problems? Like word problems?
There's some word problems in it, but I'm sorry.
Yeah, no, it's okay. Oh, terrible, it's like. Michelle, what about you? Why are you looking there? Do you have a particular...
Yeah, the logarithms and...
This one?
Yep.
Yeah, this one, okay, yeah. Ray also wanted to do some logs as well, so I think logs would be a good thing to do, yeah.
And the next page as well.
That's related to it, yeah. What question, do you have a particular question, or do you just want to practice these ones? Yeah, we'll do these ones then, okay, yeah. They need logs, yeah. Okay, so, 6 power 2x plus 3 equals 5 power 3x minus 2. Okay, so you've got paper there, guys? Yeah. Okay, we'll get started on the first question here. Now, I know you said you were totally confused, so let's see, maybe Michelle, you might know what to do first, or you want to find an example. Yeah. I think this is from the lesson on log equations. Yeah. Maybe that's like 3 lessons ago, I'm not sure. Maybe. Yeah, that's it. So, the first thing you have to do, Ray, is you put a log on both sides. Okay? So you write ln. Okay. Now, Michelle, I'm picking on you since you're the only one here and Ray's having trouble with this. What do we do next?
Then we bring down the powers.
Yeah, okay, good, yeah. Okay, good. And then the next step?
Expanding?
Yep. Okay, good stuff, Michelle. Keep going. What's next?
Then
Yeah, Ray has an idea about moving, so we have to be clear what we move to which side. So let's keep this one on the left.
And then move the 3 and then 5.
Yeah, move that one there, and you say move that one there, and keep that one there.
Yeah, because of the axis.
Yeah, that's the idea. 2 log 6x plus 2, minus 3 log 5x equals minus 3 log 6 that looks ugly. Minus 3 log 6 minus 2 log 5. Oh man.
And you have to cycle home.
Today I didn't cycle.
Okay.
Today I didn't cycle because my tooth is still sore. I had to get my wisdom teeth out last week, so I don't feel like cycling this week. You know, because yeah. Okay, what's next now? So Ray, you had and Michelle, you both had the correct idea of the rearrangement. So what do you think we could do next now?
Foil?
Say again?
Foil?
Oh, like with the brackets?
Yeah.
Not necessarily that. Something else. I'll give you a little help here, guys. So if you look up, Michelle, if you can see here, you see the way you have an x here and here. You can take that x out, so you can say 2 log 6 minus 3 log 5 x. Yeah. Is that okay with you, Ray, or not?
Yeah.
It's okay? All right. So there's only one step left, actually.
That one step is to divide by. Is it 2 and then?
Yeah. That's it. Okay.
You pop that in the calculator?
Pop it in the calculator, get the answer. Yeah. Now, it says here 3 decimal places.
No, 6.9040.
904. Is that what you got as well? Yeah. Yep, good. Okay. Yeah. This is a section A exam question. Yeah, it's like a 5-mark question. Okay, shall we continue with the next question? Yeah? Yeah. So the next one looks like it came from part of the section B question. So the first part was asking you what values of x have the logs below defined. Oh, it's shapers defined. In other words, the question is basically what values of x can you use? So you have log 5 3x plus 1 equals log 25 9 minus 8x. So the key thing here is you need to remember what you're allowed to put into log. So log can only take certain values. Do you know which values it can take? What types of numbers it can take?
Positives?
Positive, yeah. And now, can it or can it not take 0? No, it can't take 0. So you have this. You have to say 3x plus 1 must be bigger than 0, and 9 minus 8x has to be bigger than 0. So that means x has to be bigger than minus 1 over 3, and if I rearrange this one, I get 9 over 8 has to be bigger than x. Am I doing too many steps in one go here, or is it clear? Ray?
No, that's fine.
Are you sure?
Yeah.
I took the 1 over and divided by 3, and here I took the 8x over and divided by 8.
Okay.
Yeah. So that's the answer for part 1 now. So if you want to write that down, we'll do part 2.
But that's equals log what?
Oh, sorry, equals log base 25,
Okay.
9 minus 8x. You take the bus home? No.
I always exercise from this point up to the corner there, then take the bus
From the corner.
from the coming the end corner.
Dolphin's Barn.
Dolphin's Barn.
And Ray?
I live here.
Oh, that's easy. Alright, number 2, part 2. So we have to solve log base 5, 3x plus 1 equals log base 25, 9 minus 8x. Right, now we're talking about the hard stuff here. You really need to know your rules of logs for this one. You know, do you have them written down somewhere? I know you have them, Michelle. You know what I'm talking about?
Yeah, I think so. Rules of logs. Yeah.
Good. Did you find yours, Michelle? Rules of logs. So look at the rules of logs there, Ray. We need to figure out which rule to use here.
These are the rules of log worksheet.
I didn't write the rules down.
I choose the rules.
Yes, they are. Yep, they're the rules. And Michelle, you have your rules there?
Yeah, I have.
Now, I'll tell you the problem, and you try and figure out which rule you need to fix it. So if you look at this, what base is on the left? 5. And the base on the right? 25. You need a rule to make those bases the same. So which rule could that be?
Log. Oh, what it's called.
Yeah, well, you can tell me which number it is. First, second, third, fourth, fifth.
Fifth?
Correct, yeah. It's the last rule, the change of, or the fifth rule, the change of base rule. You see, you have those rules there, do you? Yeah, do you know the rule I'm talking about? The change of base rule, that I think is the fifth one. This is how it works. We'll keep this guy the same, but we want to change the base of this guy. What base would we like here? We would like it to be base 5, to be the same as the other one. Do you understand?
So
Now,
5 of 5?
Nearly. You compensate by dividing by log 525. So if you change the 25 to a 5, the price you pay is to divide by log 5 of the old base, 25. That's how the change of base works. You don't seem happy with this. Are you happy?
I was thinking of 5 squared.
Now 5 squared, I know why you're thinking that, and that's good, but I'll tell you when to use that. It's when you have 25 not in the base. Because if 25 is not in the base, you're right, you should change that to 5 squared, and you can bring the 2 down. But it's actually a little bit different if it's in the base. So if the 25 is in the base, you have to use the fifth rule, which lets you change the base from 25 to 5. Yeah, is it sure it's okay? Yeah. Now, Ray, I don't know about your calculator, but do you have the option to type in log 525 on your calculator? You do? Mm-hmm. Yeah? Okay, so type it in and see what you get.
Two.
So, it's like that now.
Okay.
Okay, now, 1 second. I'll let you catch up and then we'll continue. Got that? What do you think we should do next? What would you do next here? What's kind of the next problem to deal with?
The log?
Yeah, before the log actually, there's something else before that. What about that 2? We don't really want it in denominator, you know. So what should we do with the 2? How can we get rid of this guy?
Cross multiply?
Yeah, cross multiply. You can bring the 2 up to the left, yeah? So you have this. Are you happy with that? 2 goes up to the left, and now you're left with this. Okay, we're getting there. Now what's next? Division? No, not yet. Something before that. Now you're nearly having, Michelle. If you had, for example, log 5a equals log 5b, you can cancel the logs. That is true. But we have a small problem. We don't quite have this. What's our problem? The 2. Okay? So, if we can get rid of that 2, we can cancel the logs in the next step. So what on earth can we do about that 2 in the front? Now we don't want to bring it back under, because that would be going backwards. We need to do something else with it. We need a rule of logs. There's going to be a rule that will help us get rid of that 2. I'll help you. You're looking for a rule that has a number in the front of it somewhere.
Yeah, I don't have that.
Are you sure? Oh, you do have it. You do have it. It's this one.
Oh, the end.
Yeah, the end one. So
you move the 2 above the 5?
Oh, close, Ray, close. Not above the 5, but up here. It goes up there.
Okay.
Yeah, because you see, where's your rule?
There.
Yeah, you see how the n is not on that one, it's on that one.
Yeah,
so it goes back up there.
Alright, cool.
Is that okay, Michelle? Do you see which rule that is? Is that rule 3 or 4?
3 or 4.
For me, it's the 6th.
Ah, yeah. Well, each teacher gives the rules in their own order.
Okay,
You know?
yeah.
And the only reason I do it in this order is because that's what my high school teacher showed me. So. You can't find it? Are you sure?
I can't find the rule.
Really? Okay. You might need to write this down then, Michelle. I'll write it here on the side for you. So the rule is, if you have log bxn, that's equal to n log bx, like that. Yeah? Okay. It's the same. Okay. So, now you have log 5, 3x plus 1 squared equals log 5, 9 minus 8x. Yeah? So what should I do now? I think you might know, Michelle.
Cancelling?
Yeah. Cancel. You can now cancel the logs. So you have this. Oh, what's next? What would you do next? Ray, I think you might have an idea.
Move to other side equals 0.
Yes, yes, there's something to do just before that though.
Final? Ah, no, I don't know.
Oh, we expand here. So you can change this into 3x plus 1 times 3x plus 1 equals 9 minus 8x. Because the square means you multiply.
Yeah.
So this becomes 9x squared plus 3x plus 3x plus 1 equals 9 minus 8x. Now let's take everything to the left. 9x squared plus 3x plus 3x plus 1 minus 9 plus 8x equals 0. So that's 9x squared. 6x and 8x is 14x. And then 1 minus 9 is minus 8. We need to solve this now. What calculator do you have? It doesn't have, okay. We have to solve this quadratic. You think you can find factors? Go on. Impress me. Michelle, do you think you can find factors? Or will we just use the formula? Can we find factors? I'm too tired to find factors. Let's just use the formula. You know the formula I'm talking about, don't you? The minus b formula. You know, minus b plus or minus square root b squared minus 4ac. That's a plus now. Over 18. Michelle, when you get a chance, can you just tell me what's inside the square root? The 14 squared plus 4 times 9 times 8.
B,
Yeah. No problem, take your time. We're not going anywhere, don't worry.
minus 14.
No, don't worry about that. You can just tell me what's in the root part. I can do the other bit. Yeah, so it's minus 14 plus or minus square root of something over 18. Maybe, Ray, you could type it in as well. 14 squared plus 4 times 9 times 8.
Yeah, it changes the number. So I put 9 for B. I have to start again.
That'll be 22.
Huh?
22.
Oh, did you take the square root?
Yeah.
Oh, alright, so even after the square root is 22. Great. So that's 22 over 18 like that is what you're saying.
Yep.
So that gives you two answers. Minus 36 over 18, which is minus 2, or 8 over 18, which is 4 over 9.
Do you have to pick and reject one?
Yeah, we might have to, yeah. So we go back to the start. We need x to be bigger than minus a third and bigger than 9 over 8.
So you reject the negative 2?
Possibly, let's think about it. What did we say? X needs to be bigger than minus a third. Yeah, and minus 2 is not that. So reject and accept.
Is there by any chance we can put plus and minus at the same time when looking at the
No, sadly not. You have to do it, switch between the two, yeah. It would be handy if there was actually a plus minus button on the calculator. Yeah, that is true. Because then it could give you both answers at once. Right. This is kind of a hard question, isn't it?
Not as hard as the next page.
Yeah, they're a bit tricky. They're a bit tricky because they're word-based problems. Yeah. We got time to look at one? Oh, we do, yeah. Well, so do you want to switch to a word one now, or do you want to do more of these ones, the log ones? What do you think, Michelle?
And it's fine with me.
Are you sure?
Yeah, I think it's fine.
Then let's do the word one.
We do a word one then. Yeah, okay. Let's have a look. So, I'll read it because it's like a little story.
Yeah, actually this is supposed to be my homework, but
Yeah.
I don't know how to do it.
Well, you'll have some of it done now. Yeah, and maybe you could try some of the others now. I'll do number 2 because it's the fish one. The population of fish in a region of the North Sea is modeled by the equation. Okay, so P represents how many fish you have. Population of fish is equal to a constant time. T is time in years from 2005. So what they're saying is T is the number of years from 2005. So for example, imagine the year is now 2005. What's the T? What value would T be?
Oh, 5. Oh, sorry, 0.
0, yeah. If the year was 2006,
1.
it'd be 1. 2007, it'd be 2. Okay? You're told that in 2005 you had 3 million fish, and in 2010 you had 1.3 million. So what's happening to the fish population? It's decreasing. Okay. So we have to figure out the A and the K. So what we do is we change these statements, that's million, I'll just write M for million, into mathematical statements. So the first one says what's the T in 2005?
0.
0. When T is 0, P is 3 million. And then, Michelle, maybe you can tell me the second one. When T is, so what would the T be in 2010? Yeah, 2005 is 0. Yeah. Or it's 5. The population will be, what would it be, Ray?
1.3.
1.3 million. Yeah. Okay, is that okay so far? Are you okay with that so far, Ray? Is that okay so far? So now what we do is we sub each of these back in. So let's do the first one and then we'll do the second one. So P is 3, A we don't know, E we know is on our calculator, K we don't know, and the T is 0. Now what's K times 0?
0.
0. And E power 0?
0, so...
No, it's not actually, be careful. You can check it on your calculator.
1.
1, yeah. So that's 1. 1 times A? A. So therefore,
3 equals A.
yeah, exactly. Okay, so we have the A. Now, what do you think we do to get the K? Well, we sub in the other one now. Okay, so what's P? 1.3, yeah?
Yeah, 1.3.
Equals, what's A?
3.
And what's T? 5.
5.
Now, we have to figure out the K here. That's a little bit trickier. It's not as easy as it. Can I scroll down a little bit?
Mm-hmm.
Yeah. So I think what I'll do is I'll first divide by 3. Maybe, Michelle, you can tell me what the decimal is there.
1.3 divided by 3.
Yeah.
That's 0.43.
Sir, say again, sorry?
0.43.
Does the 3 have a little dot on it?
Yeah.
Yeah, so it means it repeats then, yeah. Now, when you're ready, maybe one of you can tell me what to do next. No, not that. We want to cancel an E.
So we introduce
Yeah?
ln?
Yeah. You see, if you put log together with an E, they cancel each other.
That's when they cancel.
Yeah. So now you have log 0.4333, and maybe, Michelle, you could calculate that equals minus 5k.
Minus 0.83.
Give us a couple more.
63.
Okay, that's right. And what's the last thing to do here, Ray? Would you say? To get the k?
Divide by 5?
Yeah, we'd say divide by minus 5, so the minuses cancel.
Yep.
What's that, Ray? You can give me that one when you're ready. When you're ready.
Um, 0.16726.
Okay, so we'll just say 0.167. Okay, there's a second part here, but it's a short one. So we have this formula now. P equals A. What did we say A was? 3, wasn't it?
Yeah.
E minus K, which is 0.167 T. So this is our result. Now on to part 2. Part 2 is what is the P in 2013? So they want to know what's the population of fish in 2013. Any ideas, Michelle? Do you have an idea? We want to get the P in 2013. So what could we do, perhaps? One of you have an idea? Yeah, what were you going to say, Michelle? I thought I heard you say it there. What do we do?
Yeah, I'm just thinking.
Yeah?
I was supposed to use that value.
Yeah, you're supposed to use this result here, yeah, to help you.
We substitute that value for A.
For A,
But there's a kind of substitution.
it's a substitution, yeah. Now, what are we substituting? It's not A because we don't have A anymore. We figured it out. It's 3.
3.
Yeah.
T.
T, yeah. So we sub in T equals what?
The negative 0.167.
That's the K, which we already subbed in. There it is there.
Oh. 8?
Yes. I saw you working there. So P is 3E minus 0.1678. So if you just hit that in, you can tell me how many million fish we have in 2013.
How do we get the
2013 is T is 8. Is 8 from
Oh.
2005.
Yeah, put the E in the calculator.
Yeah, I think your E is on the bottom or the top. Did you find it?
Yeah, I think so. Okay, got it.
What you get?
0.7886.
0.7886, so we'll say 89 then.
Million? I mean
Million.
789,000?
Yep. So, yeah, exactly, yeah. So that's 789,000 fish. I know, Ray, they all look like they're different, they're actually all the same as this one. Because if you look, if you see here, this is the example I did, okay? You notice how the first part is find the constant and make a prediction. It's the same here. Find the constants, make a prediction. Find the constants, make a prediction. Here, find the constants, make a prediction. They all follow the same structure. You know, so one example is actually enough. Number 4 is similar to this. The reason I say that, I mean they're all similar, but this is the most similar because it even uses millions as well. So here it says it starts at 5 million and then goes to 8.7 million. Like here it starts at 3 million and goes to 1.3 million. So if you wanted to try something yourself, I probably would do number 4 next because it's most like number 2 then. Yeah. And then this one here, we did these two. This one is like the first one again. This one is like the second one again. But these ones are a little bit different. This one is like the other ones again. So 6 and 7 is a bit different. Maybe we have time to do one of those. Yes, we do. We'll do 7 as another example.
All right.
Yeah. Pretty tiring week, isn't it? Pretty tiring week. What's that? Yeah, well, the weather doesn't help at all. Let's see. Right, well, look, we'll do one more example and then we'll finish. So, log base 4 x minus 3 plus log base 4 x minus 9 equals 2. So we're doing that guy there. Now, Michelle, I think your rules, well actually Ray, you have the rules as well. Would you know which rule to use first here, if you want to have a look at your rules? Yep, very good, rule 1. And there's probably rule 1 for you as well, I would imagine. Or maybe not actually. It's going to be this one for you.
Number 4.
Yeah.
Okay.
So it says that when you add 2 logs together, like here, a log of b plus a log of c, that's equal to log of b multiplied by c. So what you can do is you can change this
to log 4.
Yeah.
Bracket x minus 3 x minus 9.
Very good. Equals 2.
Oh, that's a 2.
Sorry, what did you think it was? A question mark?
I thought it was an arrow.
Oh, sorry, it's 2, yeah.
I drew a little arrow.
No. It's not a new symbol. Okay, so what shall we do next? Yeah, simplify, multiply out the 2 brackets. So you'll get x squared minus 3x minus 9x plus 27 equals 2. So that means log base 4 of x squared minus 12x plus 27 equals 2. Now, how do we get rid of the log, or what can we do next to simplify this? See, the problem is we don't have a log on the other side to cancel, do we? No. You could find what, yeah? Huh? Oh, yeah, no, we already have them. It would have been 3 and 9, yeah. Yeah. Any other ideas?
Does it involve moving the 2?
Well, not quite moving the 2, but what did you suggest, Michelle? Not quite yet, we have to get rid of the log first. Yeah, this is the problem.
Do you go back to the rules of log?
We could, but basically the problem is, it would be really nice if we had a log here on this side, wouldn't it? Because then we could cancel it. But you could think of the number 2 as just 2 times 1. And if you think about logs, is there any log that you know would always be 1?
2 and 2?
Yeah, well you could say log 2, 2. Or log 4, 4. If I write log 4, 4, that's a 1. Okay? Now can I cancel the logs just yet?
No.
Yeah, why not?
Because has a 2 in front of it.
The 2's in front. Now, do you remember what we did the last time that happened? Because it happened in an earlier example.
Yeah.
When can you remember back? When we wanted to get rid of that 2. We did it earlier today. Power, that's it. It comes up to the power, doesn't it? So what's 4 power 2? 16. Right, now we're talking. So, what happens next? Cancel the logs, isn't it? Cancel. So now you're left with x squared minus 12x plus 27 equals 16. What happens next? Good. What's 27 minus 16? Is 11, I think. Yeah, it's 11. Yeah. Now, we have factors here. So, 11 and 1. So, x equals 1 or 11. Now, you have to check that both those answers are okay, though. So, if I just go back to the question for a moment. Yeah, this is a good one. So let's check the 11 first. Is it okay if I do that?
Mm-hmm.
Yeah, I'll go back to here. Let's just check the 11. Can I put 11 into this? Yes, what's 11 minus 3? 8, isn't it? Can I take log of 8? Of course I can. There's no problem, right? And 11 minus 9? Is that okay?
Yes.
Yeah, that's fine. Now what about if I put in 1? Let's see what happens. Can I put 1 into this?
No.
Why not?
It would be negative.
Yeah. So, what happens here at the end?
Reject the 1.
Reject this one, and then accept this one.
I feel like you're one of the few that actually enjoy math.
I do enjoy maths, actually. You study it for 4 years and then you do a master's in it. You will have to enjoy it. Otherwise, why would you punish yourself like that? What is it that you're thinking of studying next year, Ray? Or you don't know? It's too early.
I have ideas.
Yeah, roughly. What's your idea?
International affairs.
Oh, good. Yeah, okay.
Just something I don't really have to do a lot of math in.
You wouldn't in that subject, that's for sure. Where would you do that?
Spain.
Nice. In English, speaking university. Yeah. And Michelle, what are you trying to do next year?
Nothing.
And where in RCSI or some other place?
No. It's quite expensive for me.
It's very expensive.
Very. What's
the fees in RCSI? It's something crazy, like 40,000, isn't it? I know, right? That's for 1 year.
Yeah.
Yeah. And how long is nursing? How many years?
3,
4 years?
4.
4, yeah.
Not even 5.
Yeah, it's tough. It's tough. Right, so I think next week we'll probably want to be doing the trigonometry, I'd say. I don't think you've started the trigonometry yet.
I've done trigonometry in high school.
Oh yeah, but you've not done the here yet.
No.
I think that's what you'll do this week. So next Friday we'll look at trigonometry, okay?
That's alright.
Alright, okay.
Still have class till 6.
You don't. Who's got class with Mark, is it? In this room?
No, Cal.
Thank you.
See you, Michelle.